Thanks a lot for the possibility to present some of our work here. And when I heard the title of your workshop here, and I think you have an exhausting week behind you, and I hope I'm able to keep you awake for the next roughly an hour. This picture came to my mind, and the first time when I saw it, I put it in a complete wrong time schedule. For me, it reminds me to, let's say, the 30s. But his scheme was developed in the mid-60s, so we are 2 generations back. And looking on the timeline for master planning, I think we have to be careful because we are doing or working on developments for 10, 20, 30 years. So at least 1 or 2 generations has to cope with that in the future. And a couple of decisions which seem to be very reasonable today might be quite hilarious for the next generations. So Trend Solar, we started 20 years ago, so we celebrated our 20th anniversary this year. And we call ourselves climate engineers. So if somebody has a better term for that, I would highly appreciate. I don't like it very much, but we didn't find anything better so far. Our idea was that we step in between the common HVAC services and the architecture, because we're convinced there's a strong link between, let's say, for example, facade design and the systems, building systems, more or less servicing the building itself. So, and there's a lack of communication and a lack of knowledge to our understanding. And by using simulation tools predicting the performance of the building at an early design phase, we try to fill in that gap. So looking at our staff, roughly 50% are classical engineers with a thermodynamic background, power plant technology, thermodynamics. We have roughly 30% physicists, and even teaming up these 2 different disciplines, we made very good experiences. So the approach to solve issues is quite different between the 2 of them. And by teaming up, we see better results. Then we have a couple of architects and a couple of HVAC engineers. So master planning, as I said, we are predicting a future. We are considering or developing solutions out of what we know now for future situations. So it's really a risky thing, but provides a lot of potential. Why we are focusing on cities? And Trend Solar, we started on a building scale. We try to do energy efficient, comfortable, high comfort, low impact buildings. And more, we were complaining about bad master planning because it's really tough to establish a good building within a bad regulation. So at least one of our clients was pissed up and said, hey guys, you're complaining all the time, so tell me how to do it better. That was more or less the starting point when we got into this field of master planning, applying or using more or less the same tools, similar approaches, and trying to develop it. And in the last 2-3 years, we're focusing more and more on cities, on urban developments, because that's one of the main issues, I think, for the near future. And why? Recently, we got over the threshold that more people are living in urban environments than in rural. More than 30% of the population of the Earth are living in informal settlements. And I think that's a very intriguing topic. So the first time when we approached projects in this kind of environment, I think it's a typical European level of arrogance that these kind of settlements seems to be very chaotic, not organized. But as soon as you get a little bit closer, you recognize that there's really a very sophisticated system in these settlements. And to have an impact, an improvement in there, you have to be very careful with small injections to improve this whole situation. And we can quite a lot of how to organize, let's say, cities from these guys. The future, and I'm always doubting a little bit numbers predicting future developments in that range, but there will be a huge amount of people living in urban environments. And if we pick out China, And if it's 120 millions or it will be 180 millions in the next 10 years, I think that doesn't matter. But these guys has to build more or less 2 times the building stock of Germany in the next 10 years to host all these people. And that will have a global impact. So that's something we should, if we are able to contribute and improve it. So in Europe, we have a complete different situation. I think it was addressed today several times. Most of the cities are shrinking, except for the metropoles, typically. So we have this very complicated situation. But you know, there were these 3 columns of sustainable developments established. So the progress of society, economical issues, and the awareness of sustainability. And looking on these 3 columns, I would say most of them are really shaking. The economical situation is changing dramatically. With the shortage on oil, the explosion on costs for energy, the changes in the social life with all the new technical stuff, the native or digital natives showing up, commuting in a new way. I think it's really hard to predict how the society will change in the next 10, 15 years, but it will be dramatically. So, and within these boundary conditions, we have another unknown, climate change. So there are a lot of models, and for sure, disastrous information is always a better sell than, let's say, more comfortable ones. But most of the models predict that this situation we had in 2003, where a heat wave more or less ran over Europe with the consequence of roughly 40,000 people dying as a direct result of that, that will be the common summer 2050. How do we deal with that situation in our designs? We have a political situation, and the EU established a kind of roadmap to reduce CO2 emissions. So till 2030, and that's not that far away, by 20 to 30%, and to 2050 by 80 to 95% compared to 1990. So I picked up some figures from my hometown, Stuttgart, in Germany. And this red curve identifies the roadmap of the EU, and the blue curve is more or less the recent situation in Stuttgart. So they're far, far away. And there are these political commitments, but in real life, looking on projects, I don't see how they want to achieve these goals within the given time period. So there's even from an economic point of view, a very uncertain, shaky situation. So for buildings, it started roughly 20 years ago that we established certification labels for green buildings. I think LEED is one of the most popular systems, and there are systems more or less all around the world. We have Macadamia in the Middle East, we have Priam, HQE in France. So, and as an extension, they developed criteria for neighborhoods or for master planning. And even looking on this criteria, it's obvious that master planning is not a one-man show, it's a team approach. And integrating all these experts, I think that's really of essence for a high-quality product. We established that more or less a couple of years ago, make it a little bit simpler for us. We have to do with emissions. CO2 is a placeholder for that. I think to achieve a vibrant urban situation, the quality of the public realm, the accessibility is a key essential. And local identity, I think, is really maybe a new parameter, but driving quite a bit. Recently, we won a competition for high-rise building in Addis Ababa in Ethiopia. And we had a first kickoff meeting with the client. And he said, at the very end, he was very pleased and everything was fine. And then he said, but I have still two questions. One question, where's the exterior shading? I highly appreciated it because the architect didn't find a way to integrate exterior shading, what we required more or less the whole process down in a kind of aesthetical way, so he skipped it for the competition. But the next question was, where is our African identity? I don't want to have an American high-rise here, I want to have an African high-rise. And how can we transfer your knowledge, your technical approaches to the local craftsmanship? So how are the social aspects related to this project? And I think from a bank CEO, I was really astonished, let's say, to have this kind of criteria for a project. And for sure, nobody wants to sacrifice quality. So we have to think about a combination of quality and high efficiency. So we talked about infrastructure today, mainly in the meaning of transportation. But infrastructure has a lot of meanings. So it's not only transportation, it's not only energy supply, it's not only waste, it's also a cultural infrastructure, social, leisure activities. And even if the guy in Berlin took, let's say, the green transportation a little bit too literally, it's important. And I think looking on master planning in the past, all the approaches developing a scheme focusing on one parameter only. In Germany, we had this hype on the car-friendly city in the 60s and 70s. It ended as a disaster. And now we're slightly trying to go back, improve the urban quality, the quality of the public realm in the downtown areas. So, and I think the advantages of public transport are obvious. So looking only on the place consumption. But especially for a situation like here, we have to think about the connection between the urban situation and the rural situation. Where are the transfer hubs where you can jump on, let's say, public transport? I think that's something which has to be developed. Come on. Recently, I got this figure, and that's a quite popular neighborhood in Stuttgart, really a very dense area. The car ratio is 70% lower than typical for Stuttgart. But 60% of all the car movements are related to leisure activities. And it was something strange, but looking on the city map, let's say parks or places where you can go for a run in the morning are not located very close to this area. So the people use, let's say, for the daily life, public transport to a very high percentage, but for these leisure activities, which was not considered really in the programming of this area, it was a little bit neglected with the result of car movements. So another point, international style. I think it came up in the 80s, and one of the prerequisites was the availability of cheap energy, highly technical buildings, so that you don't have to consider the climate or the local situation. You could do whatever you want, and you put a technical equipment on top of it to make the whole thing working. So if you go in the same place back, even a couple of decades, all the things we needed there, exterior shading, natural ventilation, was already there. Now, in American projects, we have a lot of discussions about applying exterior shading, for example. Even here in Sweden, it's difficult. And people say it's not applicable because the climate is so harsh, and 100 years ago, it was no problem. So what has changed? And this mistake, from my perspective, is not something which we did in the past. it's still happening. So here we have a comparison of different urban situations in the Middle East. If you go out in the desert, you have an operative temperature in the range of 67 degrees. If you go down to the financial district, Abu Dhabi, it's even worse. The operative temperature, the perceived temperature there is in the range of 71 degrees Celsius. It's the impact of these highly glazed, reflecting buildings. So if you go back and have a look how the people dealt with that kind of climate in the past, we go significantly down to 40 degrees. It's still not comfortable, but I would say you can survive. At 71 degrees and 80% humidity, it's simply close to dying. And if we improve the situation, we could go even further down. We worked a little bit on this master project, and I think there's a lot of discussion for this emission-free city. But we did some simple measurements, and you can measure these effects. So it's not something only in theory. So we compared, let's say, a main street and a place in the master development, and we have really a significant difference. As I said, it's still not comfortable, but you can walk there, you can do whatever you have to do in a pedestrian way. So design is really something which has a high impact on the quality, not only of the interior, but also on the outdoor public realm. And that's more or less my credo. The most important slide. Sustainable development, sustainable planning, if it's master planning or related to a building, requires communication. And it seems like a no-brainer, and it seems quite easy. But even with the first meetings, I recognize that the communication, especially between engineers and architects, is difficult. And first of all, I thought it's a typical German problem, but I experienced that situation more or less all around the world. And I was teaching for 2 years in the United States, and I had a great idea to do combined studios with engineers and architects. But approaching the dean of the engineering school, I received a nice email and said, great idea, and I never heard again from this guy. And my architectural dean, she looked at me and said, why? And this level of ignorance on both sides, I think is really a big obstacle. And I would encourage you that something, because that's your daily life, your business life. You have to deal with these guys, and communication requires a certain level of knowledge. I think you shouldn't be able to do the engineering work, but you have to be aware how these guys are thinking, what their tools are, what the limitations are. You should be able to raise the right questions in the right moment. And then, as my experience, if you achieve a tense, even a tense communication in the project, it will be a good one. So we did this highly sophisticated scheme, I would say, 2 weeks after founding the company. And it's only coincidental that this climate engineer is on top. But we think that the design team is more or less a kind of integrated team. Everybody has to bring his experience on the table, not only as an expert, also as a potential user. And in this communication and embedding the experience, the expertise of all these guys, then we're on the right way. And for sure the client has a big impact on the whole thing. So typically when we start a project, first question is, what is the impact from your work? Because you're no player in the game. And I got these slides from a business school, and they tried to analyze the design process. So we have on the lower X, the process of the design phases, and the red curve identifies the effort. And they figured out that the main peak of effort is during construction documents, when you do the detailing. So, and looking on the impact of changes in terms of costs, for sure it's obvious the later change orders show up, the more expensive they might be. On the other hand, the ability to control the cost is reduced with the progress of the design. The big decisions has to be done in the early phases, and that limits, let's say, 80% of the costs. So what we propose is more or less, to do the same amount of effort, but shift it to the early design phases. Because today we have all the tools for analyzing, for modeling, doing an assessment of the performance of different options that we can provide to the client or whoever the stakeholder is, a base for the decisions on figures, not on gut feelings. We can evaluate what the performance will be. So at the very end, it's the same effort and we will achieve better products. So this modeling closes the gap between the design and the engineering. So in addition, as I said at the beginning, we have to rely on each step. And if one step leads to a bad result, you cannot more or less compensate in the later phases. We need a good master plan. We need a good, let's say, block scale that we can achieve a high performant building scale. So each design step has to be done with the same level of scrutiny. For our field, we typically have this 3-step approach. I think the lecture before we had a 4-step approach. So first of all, we try to maximize what we call passive performance. Solar exposure, the envelope, if you talk about a building, and so on. On the second step, we look for appropriate building systems, service strategies, and the last step is more or less supply strategy so that we can maximize the use of renewable resources. The problem is that you cannot do these steps in a kind of sequential order because each of them is linked in between. So let's say there might be a resource available, but this resource with their limitations has an impact on the applicable service strategies. So you have to do it vice versa. So the design process is a kind of iterative game. We have several parameters to optimize, and each of the parameters is linked in a system. So changing one parameter might have an impact on other ones. So it's not a one-way road. We have to do these iterative cycles, optimizing, looking on the impact on others, so that we achieve, let's say, a well-balanced, well-tailored system at the very end. So as a little example, we worked on a competition for Helsinki. And as one important parameter, we identified daylight. So we worked a little bit on solar exposure. And the question was how to more or less apply that to a building scale. So we developed 2 different angles. South side, it was a kind of focus on harvesting solar energy, passive solar gains. For the north-oriented facade, it was focused on daylight. So we had these 2 different angles. And it was more or less the master plan at the very first beginning. And the architect simply applied these kind of rules very clearly, let's say, to this master plan. And it was funny how a quite vibrant pattern popped up. I think it was too scaring for the developer because I'm not sure if that was the reason that we lost this competition, but it was for us a very nice example. So I put a slide in because I suffered roughly 1 year with this little problem. In Germany, we had a hype on district heating systems, I would say 10, 15 years ago. A lot of communities invested in district heating, linked it to combined heat and power generation or waste incineration to reduce CO2 emissions, which makes absolutely sense and is a reasonable thing to do. Then more recently, the Passivhaus approach became very popular in Germany. Passivhaus means you have a highly insulated, airtight building with a mechanic ventilation and a very minimized heating consumption. So, and now the problem is that a lot of these communities have these district heating systems and then do the combination with Passivhaus. So for new developments, they require Passivhaus standard. And it seems to be logical that a good system and another good system makes a very good system. But looking a little bit more in detail, we have the problem that this district heating system has a specific loss. The piping runs through the ground, so you have some heat losses. And if you combine then a consumer with a very, very low consumption, then the losses in the ground are the main part, the major part of it. So in a, let's say, non-dense situation, we have 70 to 80% losses. And only 20% is used for the buildings, which makes it expensive. So in addition, you have to reduce the heating demand of a Passivhaus, you have to use mechanic ventilation, which is not very common in Germany for residential units. Which means that you operate with highly rated electrical energy, a ventilation system, to minimize heating consumption, which is already produced in a very efficient way with very low CO2 emissions. So if you do the balance overall, by combining these two good ideas, you increase the CO2 emissions, which is a contradictory point. And I tried desperately for 1 year to explain that to my city council. At the very end, I succeeded, but it was really a tough way. So going to a first little project, and it's not really a project. It was a development, a hospital in Rwanda, and the whole scheme was developed, I would say, within 2 hours in the coffee corner, because it's an unbudgeted project for us. And looking on the climatical situation, it's very close to the equator, but it's really perfect. It's not too hot, not too cold. The humidity is appropriate, so you don't need any kind of mechanical systems, more or less, to condition outside air. All over the year, it's very comfortable. So, and the site is in a very hilly area, and they had a problem that the technical infrastructure, for example, the supply of electrical energy was not really reliable. They used an old generator driven by diesel, and it went out of order, let's say, in a very frequently way. The problem was that the mechanic ventilation system then stopped, the systems for the surgery stopped, and the question was how to make them more independent from these technical approaches. And then this very, very simple scheme was developed that we maximize natural ventilation. We take benefit of the local wind situation there, maximizing daylight supply into the spaces. And for that, we had a long discussion with a Swiss expert on hygienics. I think the Swiss are the most experienced guys for hygienic issues. And he said, from his perspective, he's voting for naturally ventilated surgery rooms because the infection rate is directly linked to the airflow you can create, and there is no mechanic system able to create airflows which we can create by natural ventilation in this kind of situation. So even from a performance point of view, we have better results now than before. And you see it's a kind of daylight flooded space, very simple, very easy. but it was done completely with local materials. The technical installation is very limited, so the people are able to operate it in an appropriate way. The client appreciated this approach, and so the next project was coming up. It's a kind of retrofit and extension of an existing hospital, and it's a slightly different site. It's in a valley, so we don't have these prevailing winds supporting natural ventilation. So the idea was to use solar energy to drive the ventilation. So in this scheme, we have a kind of collecting solar heat, very simple, with a roof. We overheating the exhaust air, and then we have a kind of solar stack on top. And this stack heats up during the day so that we still have some energy left during nighttime hours to drive this ventilation. The advantage we have is there's no mechanical installation at all for this ventilation purpose. It's under construction, and I'm really keen to see how it will work. It's a 2-level building, so we developed a scheme more or less that we have a possibility to apply the lower level to the same solar stack, that we have more or less similar situations. I think it's obvious that there is an impact of the built environment on the wind situation, and it's not really highly sophisticated, but not considering this situation, you can create really awful places. So we're talking about, let's say, narrowing wind or redirecting of wind through the building height. And typically that's a starting point for master planning issues. So that's an example for Boston. So we have winter winds out of this direction, northwest. And the summer winds, the warmer winds, are coming more or less from southeast. Oops. So the architectural idea for this development was the Harvard Yard. So very British approach with courtyards and buildings surrounding. And so we very simply rotated it a little bit, that we block out the cold winter winds and have the openings more or less for the summer breeze. For sure, you cannot consider only, let's say, a local situation. You have to consider, let's say, the whole setup. So we have the gray buildings, which are the existing ones, and red ones as the planned new developments. So we have the situation of a edge situation where air accelerates. We have the edge combined with a tunnel. And here we have a low pressure zone which redirects the wind, creating high wind velocities in front of the other building, and so on. So you have to consider, let's say, these simple situations and their way to mitigate it. And here I want to show you a project where we applied these kind of rules. So I picked out two aspects. So for sure we worked on energy supply and so on. But I think one interesting part was the solar study we did at the very first beginning. And the question was, what is the ideal grid for this setup? It's a development in Toronto in Canada. And I think it's a very common situation. It's a former industrial harbor area now transferred into a kind of residential area. So one starting point was that solar exposure. There are a couple of rules all around the world, slightly different, but dealing with direct solar radiation on residential areas. And we picked them up and tried to focus on that. So we worked with different sizes of the streets and different orientations of the grid. So we started with north. Then we rotated it by 20%. And the last option was a rotation of 45%. And the question was, what is the impact on the solar exposure? And we did that little exercise for different street sizes. And looking on the results, I think for us it was quite amazing that the 45-degree grid more or less reduced the number of apartments with a given block situation by 50% compared to the north-south oriented grid. So that was one of the main reasons to go for a 45-degree oriented grid. Looking on the wind situation, we have it's very similar to Boston. So we have the main summer wind direction here. Let's say cold winds are more or less from northwest, and we have southwest, the main summer breeze. So then we identified, let's say, important areas to protect, pedestrian areas, areas for leisure activities in the public realm. And I think you have to be aware it's not a black and white decision. We will not cover 100% of the year providing highly comfortable situations there. But we increase the time of good conditions, let's say, by 20, 30, 40%. And that's the goal of this exercise. So we identified critical areas. So we have wind acceleration. And then, for example, here with a little recess compared to here, we reduce the air velocity significantly on the pedestrian level. So very simple geometric approaches to handle, let's say, these situations. So, and here we have a similar situation. We have a downdraft created by this little tower here with the result of high air velocities on the pedestrian level. And by rising this recess up, we could handle that. So we did this exercise for a couple of block elements, but the question was how to implement it, how to make it sure that for the next 10, 15 years of development, this kind of guidelines will be respected. And the idea to define the geometry of the volumes sounds like a ridiculous idea for us because we cannot predict what kind of program will be there. Is the, let's say, geometric approach we have reasonable if the program changes dramatically, which could happen, let's say, each day? So the problem was to be sure that there's no negative impact on the future developments. So the idea was to define very simple guidelines in terms of distance and height, and to make it mandatory that each new development has to pass a kind of wind tunnel testing. So if you sign a contract buying a piece of land there, you sign also this kind of commitment that you will go through this wind tunnel testing in a kind of predefined, organized way. So we're quite sure that these rules will be applied. So we can jump over that. At the very end, to mitigate wind, we have two main issues. We can use landscape, hedges, trees, this kind of stuff. And we can, for sure, use, let's say, the built environment. And the combination of these two leads, let's say, to the results we're shooting for. But it's obvious that it requires all kinds of experts around the table to find an appropriate way to implement these kind of approaches. The next project I want to show you is focused on a building itself. It's a high-rise in Winnipeg, Canada. And I wasn't aware that people are living in such climatical conditions, I have to confess. The first time when we arrived there, it was in the range of minus 38. But in summer, they go up to 35, 38 degrees with a high humidity. So you have a long, awfully cold winter period. And a 6 to 8 week summer period, but with high temperatures and high humidity. So it's really a very continental, dramatic climate. We had a first contact with the client. He was sending a team of people all around the world to identify best practice in green buildings. Because the board decided to put a certain percentage on top of the building construction budget, but they want to have the most sustainable building all around the world, or at least in North America. So, and I think it was the first project where we signed a charter at the beginning, more or less defining the goals, the objectives of this project. And it wasn't only all consultants signing this charter, it was also the client itself. And for example, we defined an energy target 60% lower than the Canadian building code for energy. And that was more or less before an idea even of the building existed. So it was something risky. I'm not sure what the legal consequence would be if we didn't meet the target, but it was really a ceremony when we signed this stuff, and everybody committed to a high extent to this project. That's the site before we got started. And even in the deconstruction phase, the client were very keen to separate materials and an end. I think it's not that outstanding in our, let's say, area here, but for the United States, it really was a quite aggressive approach. One of the existing buildings, come on. One of the existing buildings is a bank building, and all the partition walls were in really a good shape. And coincidentally, we run into these guys, and it's a non-profit organization doing construction for hikers in the wilderness. And so we had a direct reuse. So most of the partition walls went to these guys. They were on the way to retrofit their building so they could use, let's say, all this interior stuff. Looking on the concept, we really did a thorough analysis of the local climate conditions. And one thing we figured out was that in terms of solar insolation, they have double the amount of solar insolation in winter compared to mid-Europe. So it's a combination of really a very cold but sunny and bright climate in winter. So the main idea was to do a south-oriented building with huge greenhouses oriented to the south for harvesting solar gains. And we do a kind of preconditioning of outside air in these greenhouses. The energy supply system is based on a geothermal field underneath the building, so we have 280 boreholes. And on the exhaust side, we have a solar stack, so there is no mechanical fan to exhaust the air. If you look on the floor plan, we have here the south-oriented atrium space, and we wrapped a double-skin facade all around the building, where we control the temperature of this cavity, and we keep it always above freezing. For sure, we're sacrificing a certain amount of energy by that, but the client told us that more or less in all of their buildings, they experience serious problems with molding and freezing in winter because they have to humidify outside air with the very low outside air temperatures. So at each leakage in the facade, you get condensation and then the problems. And this approach is more or less to avoid that. We addressed for this area new technologies, so we use the whole ceiling as a, let's say, as a mechanical device for conditioning the space. So we have these pipes embedded in the ceiling. We run hot or cold water through it. So we temper more or less the whole building with it. The ventilation system only has to cover the hygienic demand, so to ensure good air quality in there. And what you see here on the left side is a mechanical space, because we bring in outside air into these spaces. In winter, we preheat it by solar gains. And then we have little air handlers on each floor, more or less supporting air into the floor spaces. On the exhaust side, we have then the heat recovery connected to the air intakes here. In addition, we have a water wall installation. It's a kind of fountain where water runs down on cables. And we use it in winter for humidifying outside air, and in summer for dehumidifying. It sounds a little bit odd to use water for dehumidification, but it's base physics. So if the water is cold enough, the air or the water in the air condensates on that cold surface, and we get the required effect. So we have the lucky situation that we are hired for a 3-year monitoring period for this building. So we have an instant contact. We look on the on the energy demand, on the operational parameters, and trying together with the facility team of the building to optimize. And here you see the result more or less on the energy consumption. So we have a significant reduction. And since end of 2011, we got below the predicted results, so we met, fortunately, the goal. But we still see some potential to further improve it. And if we put it into a comparison with other Canadian buildings, we see that we're really performing quite well. But what brings this whole thing into a more or less urban context is that the awareness of the people is really astonishing. So roughly 70% of the employees moved from, let's say, individual traffic to public transport, because they were spread in small units all over town, especially in the suburbs. And now people are reluctant to go with their own cars into the downtown area. And the guys there told me that it has a really beneficial effect even on the social life of the employees, because before, after work, they went to their car and went home. Now they share a ride in the bus or a drink in a bar or whatever. So the situation or the communication in between the people has increased significantly. For sure, let's say all these awards were beneficial, but what was more or less a very impressive thing is, let's say, the impact on the social life, even on the neighborhood. A little anecdote to this LEED stuff. LEED is, as I said, a certification label, and to get, let's say, the required energy points, we have to do a thermal simulation predicting the performance of the building. And for the Canadian LEED application, you have to use a certain software accredited for that. And we had a problem that this software was not able to more or less model the specific features of this building. So the client hired the guy programming this software, and he tried it for roughly a year, and he didn't succeed. So the client approached the Green Building Council, giving this kind of certifications, and said, we have now 2 years of monitored results, so we can explain very detailed how the building performs. And it wasn't accepted. And we had an ongoing discussion for more than 2 years with these guys. And at the very end, they agreed 8 weeks ago. So the building achieve this LEED platinum status, so the highest status, more than what was more or less the target at the beginning. But the guys told us, please don't tell anybody that we accepted it that way. So it was a little bit, so it's highly confidential. But it's a little bit odd that something which should improve, let's say, building performance shows up as an obstacle. Because if it wouldn't be really, or our client would be so persistent, more or less to keep them busy for more than 2 years with that issue, I think it would have been gone. So, and I think that's the most impressive thing. So, we have one employee of Manitoba Hydro. And Manitoba Hydro is a utility company, so they're providing electricity. And they sent him to Europe to do a kind of study or extending his studies as an environmental engineer. And he's working in our office part-time. And they made these kind of statistics. So considering the last 3 years, to 9 till to 11, more than 10,000 people toured the building. So, and only considering, let's say, 30% of them are professionals, I think this multiplication factor of this building in the professional world is really unbelievable. In addition, there's photographic bookings. So each second day, somebody is going there into this building to do a photo shooting for his wedding photos or whatever. So even, let's say, in the neighborhood, it's a kind of highly appreciated building. And looking on these public events, last year they had more or less each week an exhibition, a concert, or something. So the impact on the revitalization of the downtown area, it's really incredible. And the main feature, which is really a kind of, people are stopping in the street and showing up the building, is we applied natural ventilation for it. Because even in this harsh climate, we have roughly 30% of the year with appropriate outside conditions for natural ventilation. And people said, in a mechanic mode, air quality is really amazing. But opening up the windows, that's gorgeous. So we have automatic flaps in the exterior skin of the facade. So, and as soon as we have appropriate outside conditions, these flaps open. And really, people are literally stopping in the street and watching this kind of very scary thing. The whole facade starts to move. And then the people have more or less manual flaps on the interior. They can open if they want or not. And that's something which is totally common, I would say, for us. In this United States environment, it's a miracle that it works. So looking a little bit on the outdoor comfort, and I leased this slide from Jan Gehl from Copenhagen. And I never had thought about this situation, but with the slide, he tries to say, in the past, you have to use the public realm for business, for whatever, a lot of activities. Today, we achieved a level where it's not necessary anymore to use the public realm. The cyber kids could sit in his flat, could order his pizza via internet, could do his bank jobs via internet, could do his business. So to provide a vibrant urban life, you have to provide quality to the urban spaces. For sure, we have the lucky situation that the car innovation, how he's calling it, is reduced more and more. People are not accepting that they're tortured by these cars. So the focus on public places gets really more and more important. So outdoor comfort. Here's a little example from a complete different climatical area. We had a request from the mayor of Muscat, and they want to improve, let's say, the local conditions in a lot of places. They're looking to translate slowly to a high-quality touristic operation, and for that they want to improve at certain spots outdoor conditions. So the question was, what can we do in our climate to make people feel more pleasure? So perceived temperature. Perceived temperature considers air temperature, air humidity, wind speed, and mean radiant temperature, which means the temperature radiated by the built environment. So, and that gets very close to what you feel. And we use this tool, supplied different measures, did some simulations. At the very end, we developed a kind of catalog, identifying measures with the specific parameters, so they can use it more or less in a very easy way, what they want to apply, what is the level of comfort they want to achieve at a certain place. And it's a kind of, escalating hierarchy. We did this calculation for one example. It's an open fruit market. And the question was, what can we achieve with very low, very simple approaches? What is the reasonable thing to do? So, I'm fighting with this guy. So now we're jumping back to my hometown. And I think we had a very simple African project, we had a more technical North American project. And so I have to speed up a little bit. Now we have a simple German project. These guys provided, it's a private association, and they had the idea to provide a cultural space or a place for alternative culture. So they founded a little company, and they had a warehouse in the suburbs of Stuttgart. It was very successful, but the climatical conditions were harsh, awful. So then they approached the city, and the city donated a site for them. And we worked roughly 15 years from the very first beginning, raising the funding, raising money, till the very end. The scheme is very simple. So we go in, we have a ground-coupled earth duct for preconditioning outside air, preheating winter, pre-cooling summer. Then we enter the theater space, and then we go up through an air stack. If we don't have enough airflow, because by code we are requested to provide a certain amount of air to the space, then this flap closes and a fan ensures that we have enough airflow through the space. For sure, the whole system is designed for natural airflow, which means low pressure drops, big sections. So the fan benefits for sure from this design because we need roughly 10% of a typical fan power to move, let's say, this amount of air. In winter, we have a heat recovery system which recovers roughly 50% and leave enough heat in the exhaust air to drive, let's say, the air exchange. So we did a lot of calculations, a lot of proceedings in this kind of development. But due to the lack of budget, we reduced the system step by step. So at the very end, it was a very simple thing, very cheap, because we have to do this excavation to reinforce the existing foundation. And so we had this void, and we filled it up with our air ducts. That's the base of the exhaust stack. It's a landmark protected building, and we had a long discussion with the landmark committee to improve that. And that's the final issue. So here's the total hall. The big stage. That was more or less the hall at the beginning. So the impact on the neighborhood is really extraordinary. They have roughly 300,000 visitors a year, which is more than 3 times higher what they predicted at the beginning, with all the benefit, let's say, on the hotels, on the restaurants, on the area side. So I skipped that. I think you know your town better than I do. So just wrapping up, I think it's risky to give a lot of things away. I think the architect has to be the counter, the center part of it. And in Germany, he has a very, very strong position because legally he's more or less in charge of everything. So if the client wants to sue somebody, he always sues the architect. So it's more or less in the own interest of the architect to get everything working very well. So, and I think engineers should contribute, but an aesthetical core is required. And this strong position of the architect, I think, is one of a prerequisite to achieve high quality for a fair price. So, at the very end, I would like to focus on the methodology. I think this communication within the design team and this open-mindedness from all the involved people is really a prerequisite to achieve good projects. And we are in a prototype business. We cannot reproduce one design for another site. The site is different, the climate is different, and the cultural difference might have an impact on the design. So we have to be aware that even if you pick up, let's say, same components, it might be a different setup. And even if the site is scaring, there's always a positive aspect. Maybe from time to time it needs something to dig it out, but it is for sure somewhere. Thanks a lot.